This is the first class of my intermediate algebra course. Today I'm going to give an introduction to the course, and we're going to talk about how to stay organized and the course content. The prerequisites for the course are beginning algebra, also called Algebra 1, and geometry. If you have not completed these courses, you can take them on my YouTube channel. And if you have finished these courses, but you suspect that you may not have learned what you needed to, again, you can take them on my YouTube channel. Here's where we are in the math sequence. Intermediate algebra is traditionally an 11th grade course, but I want you to be very aware that your grade level or age doesn't really matter. You can take this course when you're 6 years old or 60 years old. All that matters is that you have these prerequisites fulfilled. And the purpose of this paper is to explain a little bit why math is so important in the academic system. The biggest obstacle that students face really is mathematics. That's not necessarily true in the real world, but in the academic world, math is really the key to success. And if you want to give yourself an edge, if you really want to catapult yourself forward, then you need to focus on mathematics. Now, the way it works in the school system is students will take a year of algebra in their first year of high school. Then they'll do a year of geometry, and there's almost no algebra in the typical geometry curriculum. Then they'll go into intermediate algebra, and because students spend so much time, an academic year, with almost no algebra, they have to review a lot of the algebra that they learned in beginning algebra once they take intermediate algebra. And that's so much so that sometimes half of the intermediate algebra curricula is just review of beginning algebra. Sometimes even 3/4 of an intermediate algebra curriculum is just review of beginning algebra. So that's a very inefficient way to do things. We are going to review a lot of algebra, but I'm going to combine that review with some upper mathematics, so you're not going to get bored. We're going to kill two birds with one stone, so to speak. Now, intermediate algebra is kind of a fork in the road. There was a report commissioned by the Secretary of Education called the Final Report of the National Mathematics Advisory Panel in 2008. And in this report, they said the following: the probability that a student will enroll in a 4-year college correlates substantially with completion of high school mathematics programs beyond the level of Algebra 2. Algebra 2 is another name for intermediate algebra. They go on to say, in fact, students who complete Algebra 2 are more than twice as likely to graduate from college as students who lack such preparation. Although such correlations do not establish cause and effect linkages, they are clear and notable. The reason for this is after you complete intermediate algebra, pretty much every math course after is going to be a college level course. So this represents an important point in your math education because you're starting to make the transition into college level work. Also, if you finish intermediate algebra, you'll have 95% of all the math that you need to start to prepare for the SAT. Not so much the ACT, but the SAT. And another exciting thing about intermediate algebra is that once you finish, you'll be able to take your first college-level chemistry course. And chemistry is one of the 3 primary sciences that are required for a lot of different degrees, including pre-med, people who want to become doctors. There is a prerequisite for chemistry, a chemistry course that is recommended, but I've actually taken that course, and I would say it's probably best just to go straight into college chemistry. The prerequisite is not really enforced as math prerequisites are. So this is an exciting point in your math education because you're getting to the point where you're almost ready to go into college level work. There is no textbook required for this course. I'm going to provide all class problems, homework problems, answers for problems, practice tests, and the tests themselves. But it might be good to get a supplementary textbook just to compare my curriculum. You don't have to, but you can go on Amazon and find books for $5, $10, $15. Just be sure that you do not buy a textbook that uses the integrated pathway, because that pathway is hopelessly confusing. And I've worked with many students who attend schools that use the integrated pathway, and it's been an absolute train wreck. You want to stay away from the integrated pathway. Also, if you're going to buy a textbook, try to get one that's designed for a remedial course in a community college, because those textbooks focus on things that are actually going to prepare you for upper mathematics. K-12 textbooks, books that are specifically designed for the K-12 system, are very disorganized and incoherent. They don't really focus on the main subjects that you need to, and we're going to talk about that more when we go into the curriculum part of this class. So you need a calculator for this class. Now, this is a point in your education where you're going to start to be expected to know how to use a graphing calculator. Eventually, you're going to need a graphing calculator for certain things. For example, if you want to go into calculus, when you take the AP exam, you're going to need a graphing calculator. You can't take that exam unless you have a graphing calculator. Also, a graphing calculator would be very useful for certain college entrance exams. It's useful for the SAT, for example. And so you need to start to get used to using a graphing calculator. Now, I don't require you to use a graphing calculator in this course. In fact, I don't want you to use a calculator for the purpose of graphing. I'm going to show you how to graph without a calculator. But nonetheless, you really need to get a graphing calculator to start to learn how to use it. Because I don't want you to get to the point where you have to use one, but you may not have any idea how to use it, and it'll catch you off guard. So if you go to these links will tell you the calculators that are approved for the SAT and ACT college entrance exams. You need to buy one that is approved. Don't waste your money buying something that's not approved. Now, I highly recommend the Texas Instruments 84 Plus, not because it's really the best calculator, but just because there's so much information out there about how to use it. That's just the basic one that every student gets, pretty much. Now, don't get the color edition, the CE edition, or any other calculator that uses a rechargeable battery. I can't tell you how many times I've been working with students, and I'll tell them to get their calculators out, and they'll say, well, I can't, it's not charged. They have these rechargeable calculators, and students forget to charge them. So there are some students that they never use it because it's just never charged. So you don't want to have to deal with that. You want to use the disposable battery version. And when you put those batteries in the calculator, it'll last for 6 months. And then you can just keep a spare set with you in case the batteries do go out on you. Now, I don't require you to get a graphing calculator in this course. I highly recommend that you do. I would prefer that you go out and go ahead and buy one right now. But in this course, you're not really going to need a graphing calculator. You can get a scientific calculator if you choose. They're a lot less expensive. Graphing calculators cost, if you buy a new one, it's probably going to cost at least $100. So a scientific calculator would be cheaper. And you can also use the factory installed calculator on the iPhone. So if you don't have the money to buy a graphing calculator, then you can use these options. But again, at some point, you're going to need to get a graphing calculator. And there's so much that you need to know when it comes to being comfortable with that graphing calculator that I really recommend that you buy one now to start to get used to it. Now, this course is going to work the same way as all my math courses. The absolute minimum that you need to make progress in this course is to watch 2 videos per week, and each video has a homework assignment. So you're going to do 2 videos per week and 2 homework assignments per week. You cannot progress any slower than that if you want to learn this material. Now, some people are going to say 2 videos per week doesn't really sound like a lot. Well, that's actually a lot of work. My videos are maybe an average of an hour and a half in duration. I'm going to be telling you to stop the video and do problems that I give you. So the videos are going to take probably at least 2 hours. And you're going to do a homework assignment on top of that. So that's actually a lot of work. Now, some people are going to say, wait a second, I have a young child. I don't think he or she can get through a 2-hour video. Well, your student can get through a 2-hour video as long as you make him or her understand that there's only 2 videos per week. That's it. 2 videos per week. Your student can do that. It doesn't matter what the age or the grade is. As long as students understand that that's all they have to do, 2 videos per week and 2 homework assignments, and that's their math education. As long as they understand that, they can do it. So just make sure that they sit down and get to work. Now, I want you to be aware that if you want to move more quickly through this course, I highly recommend that. Speed is very important when it comes to mathematics. But just be aware that if you do any more than 2 videos per week, it's possible that you could start to get burnt out. And that would be very dangerous. So if you're highly motivated and you want to spend a lot of time watching videos and doing homework assignments, you can get this course done a lot quicker. But just be aware that the limiting factor, and this is one of the most important things we need to talk about in this class today, is the limiting factor when it comes to speed through this course is the homework assignments. You can watch 10 videos in 1 week, but that doesn't prove that you know anything. The homework is going to prove that you know something. And a lot of students would say, well, I don't think I really need to do the homework. The homework is the most important part of this course and any math course that you take. I'm going to tell you over and over and over again throughout this course that if you don't do the homework, it's a 100% guarantee that you're going to learn absolutely nothing in the entire course. Homework is the basis of this course and every other math course that you're going to take. So the homework is not an option. The homework is where you actually start to learn. It's when your mind is working at 100%. When you're watching a lecture, your mind is really not working even at probably half the capacity. So the homework is going to be the determining factor when it comes to your speed, because you might be able to watch 10 videos per week, but you're not going to be able to do 10 homework assignments, most likely. Now, I feel compelled to mention the relative speeds that you can move through the academic system. A lot of students feel like school is a prison sentence, and to be honest with you, it is. I attended public schools for 21 years, and I was miserable. A lot of students are miserable. And I'm sure you've noticed that there are many kids bringing guns to school and shooting their classmates and their teachers. There's a lot of students in the school system that are just not happy. And I believe, well, I don't believe, I know that one of the reasons this is that they feel trapped. They feel that they have to be in this system. But I want you to know that you can take control of your education. In the school system, it takes 14 years to finish the math sequence, and math and English determine your grade level. So if you excel in math and English, then you can determine what your grade level is. Your grade level should not be determined by age. In the school system, it takes 14 years and the dropout rate is 99%. That means if you start with 100 students in arithmetic, by the time you get to calculus, there's going to be maybe 1 student left. So it takes you 14 years to finish the math sequence, and 99% of students fail. But in the community college system, it only takes about 4 or 5 years to finish the math sequence. You can move 3 times the speed. Why is that? In the community college system, they used to have these huge remedial math programs. I don't know if they have them anymore because of things related to COVID. I assume they've actually knocked out a lot of these courses. But they used to have huge remedial programs, and if you go through the community college system, you can finish much, much quicker. And the reason for that is that K-12 schooling is mostly daycare service. Most of what you do in K-12 schools has nothing to do with preparing for college. So if you take away all that time, that wasted time, and spend it actually preparing for college, you can move, like I said, at 3 times the speed. Now, even the community colleges tend to waste a lot of time when it comes to administrative stuff and reviewing. For example, if you take intermediate algebra, sometimes half or 3/4 of the course is just review of beginning algebra. I mentioned that previously. That's a huge waste of time. Now, you do have to do some review in intermediate algebra, but 3/4 of the course reviewing beginning algebra, that's just a huge waste of time. And the reason for that is that students are oftentimes coming from different backgrounds. So the teachers have to put a lot more material in the course it's reviewed to make sure that students are able to catch up. But with my curriculum, you don't have to do that, because I'm assuming that you're taking my courses back to back. So you can even move faster if you're outside of the school system. So the school system requires you to move at this pace. But if you're out of the system, then there's no limit really to how fast you can move. Well, there are some limits. I mean, you can't finish the entire curriculum in 6 months, but you can go as fast as you want pretty much. A lot of homeschoolers have the mentality that they don't want to give their student grades. And the reason I say homeschoolers is because obviously a lot of people that may take my courses are homeschoolers. Not everybody, but homeschoolers typically don't want to give their students grades or scores. But the problem is that's not really preparing your kid for college or for the academic system. You need to show your student how he or she is performing on homework assignments and tests. And so the best thing for your student really to prepare for college is to have a detailed score report on each homework assignment and tests. And I'm going to show you how to scale your homework score in the last class of the course. There's going to be 4 tests, 100 points each, and one final exam that's 200 points. And again, a lot of parents and students would say, well, I'm homeschooling, so I don't need to take tests. Well, how are you going to figure out if you know the material? It doesn't really make sense for parents or students to determine whether or not they actually know the material. Let me determine whether or not you know the material. My way of figuring out whether or not you know the material is for you to do the tests. When I tell you to take a test, do it. Do every single thing that I tell you in this course. I need to make sure that you're ready. Your parents may say that you're ready. You may say that you're ready. I need to determine whether or not you're ready. If you take my course, then that signifies that you're ready to go on to the next level. But you have to do what I tell you to do. So these tests are really important. They're going to determine whether or not you know the material. If you take a test and you fail that test, then that tells you that you really don't know the material. You think you know the material. Your parents may, your parent that's homeschooling you may tell you that you know the material. But if you take a test and you fail it, then that means that you're going to have some problems in the academic system. If you don't do well on a test, then that's okay. You can take the next test and improve. That's the whole point of this course, to actually prove that you know something. You're going to add up your points and you're going to determine a course grade. Now, when you apply to college, if you're a homeschooler, they don't really ask for your grades. But you need to know how well you're going to perform in school, and that's what these scores on tests and homework are going to tell you. Now, a lot of people who are homeschooling are going to say, well, I can't really score my students' homework because I don't really know the math. And even if you do know the math, you may not have the time to do that. If you want me to do it for you, I'd be happy to do that. I could use the money. That's not really why I designed this school. But if you'd like me to score your students' homework, I'd be happy to do that. But obviously I can't do it for free. And I can score your students' tests also, so let me know if you want me to do that. But if you can't afford to pay somebody to score your students' work, That's okay. What you need to do is I provide all the answers to tests and homework. You need to figure out if you're doing the work properly by looking at the answer. Make sure you got the right answer. But also, you need to make sure that you're showing some of the work. Obviously, if you have the answer, some students are going to say, well, I can just write the answer. I don't have to do anything. But if a student doesn't show work, then you, as the parent, you can just simply ask a student, explain how you did this problem. And if your student has a blank stare, you know he or she's not really doing the work. So you can still check the work and the answers and test the student to make sure that he or she is actually doing the work. You don't necessarily have to pay somebody to score the work. Now, a lot of students, like I mentioned, are going to say, I think I'd just prefer to skip the homework, but I just want to reiterate, no one in the history of mankind has ever passed a math course without doing the required homework. It's not possible. Some students are going to say, well, I'll be the first one to do it. But you will not be the first one to do it. You either do the homework or you learn nothing. The homework is required. Your homework must have 4 characteristics. It must be complete, correct, neat, and in chronological order in your binder. If your homework is complete, if you do every single problem, but half the problems are wrong, well, you didn't really do the homework. If you do the homework correctly, but you only did half of it, then that means you really didn't do the homework. If you do the homework completely and correctly, but you can't read it, again, you didn't really do the homework. And if you do the homework completely, correctly, and neatly, but you lose it, then again, you didn't really do the homework. So your homework needs to have these 4 characteristics. 95% of my classes are going to be doing practice problems. Lecturing really is not an effective way to teach when it comes to mathematics. Math is the type of subject where you have to actually engage. It's like if you're learning a foreign language, you need to actually speak the language or else you're not going to learn it. Math is a language, and you need to be able to speak the language fluently, and the only way that you can learn how to do that is by performing practice problems. So most of my videos are just going to be practice problems, and 50% of those problems you're going to do yourself. I'm going to tell you to stop the video and do the problem on your own. Now, you can use the left and right arrow keys on your keyboard to jump forward and reverse in the video, on a YouTube video that is, or the L and J keys to remove 10 seconds forward or reverse. You probably already know that by now if you're a student who uses YouTube a lot. If you get tired of hearing me talk, then you can skip forward through what you need to skip forward. And these are all things that I'm sure students already know, but you need to be able to take a screenshot. You can look at this information on a PC. You hold down the Windows button and push the part screen button. And on a Macintosh, you hold the Command and Shift button and press 3. But if these things don't work, you can just go on Google and figure out how to take a screenshot with your device. With a phone, you hold down the home button and the lock screen button, or the lock screen button and the volume buttons, I believe, on the newer phones. So that's pretty much it when it comes to the introduction to the course. Now we're going to talk about how to stay organized, because you're going to keep all your work in a 3-ring binder or a digital notebook. So there are 2 ways that you can stay organized. You can stay organized with a 3-ring binder, or you can get a digital notebook. Now, a digital notebook is probably going to cost around $1,000, so it's not cheap. There are some inexpensive iPads, relatively inexpensive. You can get an iPad for $300 that can be used with an Apple Pen. The Apple Pen, last time I checked, costs about $100. And after tax and maybe getting a case for the iPad, it'd probably be about $500 out the door. The problem is you only have about 64 gigabytes, and that's really not enough. So you're going to need to spend probably more than $500. So it's very expensive to go to the digital route. But you don't need to go to the digital route. You can use a 3-ring binder, and this route over here only costs about $30. There are positives and negatives to each, but let's go to the 3-ring binder route here. Your binder needs to be about 1 inch thick. Do not buy a binder that's less than 1 inch thick, because you won't be able to put your portable 3-hole punch inside it, and it just won't fit enough paper. Also, be sure that your 3-ring binder has diagonal rings. These diagonal rings allow you to carry more paper, and it also protects the paper. I don't know why people are still making circular rings in these 3-ring binders. It's an inferior design. The circular rings will actually damage the paper. So be sure to get the diagonal rings. Now, please understand that the things that I'm about to tell you are not optional. These are a requirement in my course if you go the 3-ring binder route. There's a reason that I'm telling you to buy this stuff. It makes a huge difference. These things add up. A lot of students will say, well, I don't need to buy this stuff. I have my own way of organizing things. You're not going to use your way of organizing things in this course. You're going to use my way. I want you to get off on the right foot from day one. I can't tell you how many times I've sat down with students and they have their own way of organizing things, and it's always inferior. There's always something that they're doing that just does not work. It is absolutely essential that you know the right products to buy. There's huge differences in the different options. This is the best way to stay organized. So this is mandatory. For example, you need to get mechanical pencils. A lot of students are still using the old style pencils. Why would you do that? As soon as the pencil runs out, you have to get a sharpener. Why not just get a mechanical pencil? That way when it runs out, you can just push the button on top. Now, don't buy these types of pencils, because if the eraser runs out and you put a replacement eraser on top, it interferes with the function of the pencil. So you want to get these Papermate pencils. I don't know if Papermate's the only company that makes this particular model, but with this model, you can easily put a replacement eraser on top if the eraser runs down. And also buy replacement erasers, of course. So again, I know what you're going to say. You're going to say, it doesn't really matter. I'm just going to get these. Well, it does matter. That's why I'm telling you. Don't waste time and energy and cause a lot of problems, because again, I've been working with students for 15 years, and I can tell you that if you don't get the right products, it's just going to cause problems. Also, get a portable 3-hole punch. One of the reasons that you need a binder that's at least an inch thick is you need to put this 3-hole punch inside. Students need to learn how to keep all of their papers in one place. That's the whole idea behind a 3-ring binder. All your papers, your notes, handouts that are given in school, they must be all in one place, and they must be in chronological order. So if students get a handout in school, they need to have this in their binder so they can take it out, put holes in it, and put it in the binder. If they don't put holes in it, then here's what's going to happen. Students are going to put the paper in these sleeves, and then the paper is not going to be in the correct order, and the paper is eventually going to fall out. So never, ever, under any circumstance, ever put papers in these sleeves. So you're going to need a 3-hole punch. But if you buy a 3-hole punch, or I should say when you buy a 3-hole punch, don't buy these transparent plastic versions, because if students drop these one time, they're going to shatter. They break. Be sure to get this this type of 3-hole punch here. Also, get some reinforcement stickers just in case. These are all things that students need to have in school in order to be ready. And in my school, in my internet school, I'm going to require you to stay organized and keep all your papers together, so you're going to need these things. For the same reason that I don't want you to put papers in these sleeves. I don't want you to buy folders. A lot of students buy folders and they put all their papers here. It's absolutely ridiculous. It does not work. Do not buy these folders because you cannot keep your papers in order. Students are going to say, yes, I can. I can just put them in and I can just thumb through them when I need to find papers. That's ridiculous. You don't have time to thumb through papers, and also it's important to understand that all you have to do is drop one of these folders once, and all the energy that you put into organizing the papers and putting them in chronological order will be for nothing. All you have to do is drop them once, and then all that time you spent organizing is out the door. With spiral, and again, that's the whole purpose of a 3-ring binder, is to keep your papers in chronological order. The papers will stay in here. They won't fall out. That's why you don't put papers in the sleeves. Again, the problem with a spiral notebook is if you're given a handout, where are you going to put it? You can't put it here. So again, that's another reason to get a 3-ring binder. If you get a handout, you put holes in it with these hole punches, and then you put it in your binder and it can't go anywhere. So these are the absolute fundamentals when it comes to staying organized in school, and this is how I want you to do it for the rest of your academic education. It's not just this course. So that is the 3-ring binder route. The benefit of the 3-ring binder route is that it's a lot less expensive, and you get a hard copy of your work. So let's talk about the digital route. Schools have spent billions of dollars on computers, and computers have done some good for students in the school system, but for most students, computers haven't really made a huge impact on their education because they just don't really use the computers for much, or they might have a personal computer. Everybody has a personal computer at home these days, so you don't really need a computer at school in order to use the Word program. So what do students use computers for? Well, I mean, when I was young, I was actually playing Oregon Trail, and it was a fun game, but the truth is it didn't have any educational value. I remember one time I was taking a physics course, and the professor pointed to 20 or 30 computers, brand new, beautiful Dell computers that were bought for his class, and he just looked at the computers and said, I don't know what to do with these things. They just sent them to me. A lot of times, money is wasted on computers, but I can tell you that when it comes to these devices, when it comes to the academic world, these devices are actually helpful. And one of the reasons that they're so helpful is that students love using them. Students love using the digital pen. These devices are a huge positive impact on students. Anything that you can do to motivate students to do work, academic work, is something you should explore. I have worked with students who don't want to do the math, obviously, and they don't really look forward to seeing me because they're going to have to do the math, but they look forward to seeing me just so that they can use my iPad. When I work with students, I allow them to use my iPad, and they enjoy using the iPad. One time I showed up and it was raining, and the student says, "Where's your iPad?" And I said, "Well, I couldn't bring it. I didn't want it to get wet." And she was pretty disappointed. Students love using these devices. Now, again, you don't have to go the digital route, but if you do use this method of staying organized, OneNote is a very powerful program that's part of the Office package. Most people know about PowerPoint, they know about Excel, and they know about Word, but a lot of people don't know OneNote. OneNote is a note-taking program. It's a program where you can type. You can see I'm using OneNote now. You can type words, but you can also use a digital pen, which I'm using now. And OneNote is a very powerful program for using digital pens with, and you can see here it makes it very easy to organize your notebook. At the left I have a notebook. It's called Overflow from Intermediate Algebra, and down here I have dividers. These are sections, and in each section you have pages, And as you can see, I have some of the classes that I'm teaching. It's very easy to stay organized. Now, as with almost all Microsoft programs, there are problems, there are bugs, but that's just the way it is with when you're using a PC. For example, there's a lot of syncing issues and various things, but you can get around those problems. I may choose to use a different software program in the future, but 95% of the time, OneNote works very, very well. So as of now, I recommend using OneNote. You can get it in the App Store if you use an Apple device, or you can get something called Microsoft or Office 365, and it's not very expensive. I think it's like $70 per year to be able to use Word, PowerPoint, OneNote, and Excel. Now, you can get a 2-in-1 laptop, or you can get an iPad. Those are the two options for hardware. There's a huge market for 2-in-1 laptops. That's a laptop that you can use as a personal computer, but you can also flip the screen over and use it as a tablet. And the big benefit of these 2-in-1 laptops is they're compatible with a pen. Just make sure you get one that says Windows Ink. Windows Ink just means that it's compatible with a digital pen. If you buy one of these and it does not say Windows Ink, well, that's going to be a waste of time. The most common pen that's used is the bamboo pen made by Wacom. Now, the second option is an iPad. You don't have to buy an iPad Pro. They're pretty expensive. You can just get the basic iPad. I believe, I'm not 100% sure, but I'm pretty sure that all iPads that they make these days are compatible with the Apple Pencil. It used to be that only the iPad Pro was compatible, but now I believe all of them are. And of course, you have to buy the Apple Pencil. So, which one should you get if you decide to go this route? If you have a personal computer and you can't use a pen with it, then I would buy the iPad, because the iPad really is more practical for this application. You can take it. It's more mobile. You can take it on trips with you. It's very easy to work with, and the battery life is very, very long. The battery life with PCs is really, really not good at all. And even when you're sitting on the couch, it's just much easier to use the iPad than the tablet or the 2-in-1 laptops. But if you don't have a PC already and you need one, and your parents may not let you buy multiple devices, then I would get a 2-in-1 laptop, because that will be a personal computer for you, but it also will be something that you can use with a digital pen and to keep your notes in order. If you have a lot of money and you can afford to buy both of these, I would actually buy both, because you can sync the devices, and if one of them fails for some reason, you can use the other one. I actually have a Yoga 720 Lenovo 2-in-1 laptop with 512 gigabytes of RAM. It's not the best computer that you could buy out there, but it's fairly good. And I have an iPad Pro, but again, you don't have to buy the Pro version. And one of the good things about these devices is that if your device is stolen or you drop it and it breaks, all of your data will be in the cloud. As long as you sync regularly, your data will be in the cloud. Of course, the downside to this is if the cloud is corrupted for some reason, then you've got a big problem. So there are benefits and negatives to each one of these ways of staying organized. But I just want to say one more time, you don't have to buy a digital notebook. Okay, so don't think that you have to buy that. A 3-ring binder is fine. All right, so let's move to the course content part of this class. So this is my curriculum, and I want to start by saying that intermediate algebra curricula vary wildly depending on the teacher. So there are going to be some differences between my curriculum and other curricula. But I want to start by reading a quote from a report commissioned by the Secretary of Education in 2006. They say the educational achievement levels of our young people who do complete high school are simply not high enough to allow them to succeed in college. According to the National Assessment of Educational Progress, only 17% of seniors are considered proficient in mathematics. They go on to say, ample evidence demonstrates that a key component of our national achievement problem is insufficient alignment between K-12 and higher education. Studies show the overwhelming majority of both college and high school faculty and administrators are unaware of the standards and assessments being used by their counterparts in the other sector. For example, only 8 states require high school graduates to take at least Algebra 2, a threshold course for college-level success in math-based disciplines, including engineering and science. Fewer than 22% of the 1.2 million students who took the ACT college entrance examinations in 2004 were ready for college-level work in the core subjects of mathematics, English, and science. Only 1 out of 4 students graduate from high school. And in the community college system, the graduation rate is about 1%. And in the 4-year colleges, graduation rates for most of them are in the teens or the 20s or the 30s. And even in the top tier colleges, sometimes 1 out of 5 students don't graduate. So why are students having so many problems when it comes to college and the STEM fields? Well, the reason that they're having so many problems when it comes to being prepared is most K-12 math teachers don't know what to focus on in the curriculum. And the reason they don't know what to focus on is most of them don't have STEM degrees. And because they don't have STEM degrees, they don't really know the primary objective of intermediate algebra, the curriculum. The primary purpose of the intermediate algebra curriculum is to prepare students for the possibility that they might take calculus. But because so many K-12 teachers have not taken calculus, they were not required to take calculus because, again, most of them are not STEM majors. Because they never took calculus, they don't understand that that is the primary purpose of algebra in high school. Many of them think that it's really not even that important, prepare students for calculus, because most students in the United States don't earn STEM degrees, and one of the reasons for that is they're not prepared properly, so when they try, they fail. But another reason is they don't understand the huge restraints when it comes to earning a STEM degree. If you try to earn a liberal arts degree, you may have 1 or 2 prerequisite courses that you have to deal with, but other than that, there's really not a lot of restrictions. When it comes to the STEM fields, there's restrictions all over the place. But again, most K-12 teachers have not earned a STEM degree, so they don't really know this in depth. So let me give you an example. Let's say that you want to take a engineering course. You might find out that there's actually a prerequisite engineering course. So you cannot take that course unless you take another engineering course before that course. But then when you go to take that prerequisite engineering course, you find that that course lists vector calculus as a prerequisite. But then you go to take vector calculus, and they tell you, well, you can't take this course. You have to take Calculus 2 before taking this course. Then you go to Calculus 2, and they say, well, sorry, you can't take Calculus 2 until you first take Calculus 1, and on and on and on. Another example is at my alma mater, in order to take a general biology for pre-med students and scientists and the core general biology course, in order to take that course, you have to first take organic chemistry. But you cannot take organic chemistry unless you first take general chemistry, and you can't take general chemistry until you first take intermediate algebra. Again, the STEM fields are full of these restrictions. If you want to be a chemistry major or math or engineering or computer science, statistics, astronomy, physics, you have to take 4 semesters of calculus. And these courses are all considered to be in the first 2 years. If you try to enter as a freshman in college and you want to earn a STEM degree, if you're not prepared when it comes to the math or the science, oftentimes the college will not even allow you to choose that degree pathway. A lot of people say, well, if I want to choose art or philosophy, sociology, history, and I change my mind, I can just decide to go into the STEM fields, but that's not how it works. If you're not prepared when you enter as a freshman, the colleges won't even allow you to choose those degree pathways because they know not only are you not prepared, but you don't even have enough time. When it comes to biology, medicine, economics, geology, architecture, pharmacy, optometry, all these degree programs require the Calculus 2 level, and so on and so forth. So that is the primary purpose of this curriculum, is to prepare you for calculus. So hopefully I've convinced you, or at least I've given you some things to think about. That's what we're doing in this course, is we're preparing for the possibility that you might take calculus, because you will lose that option if you don't start preparing, if you don't have intermediate algebra finished, and you really need to finish trigonometry and pre-calculus to be properly prepared for the transition into college. If you don't have those courses done, then the option to choose a STEM degree disappears. When it comes to entering college as a freshman, you will not have that option. And a lot more students, as I mentioned, a lot more students would choose STEM degrees if they could succeed, but a lot of them fail because they just don't have enough math and science. So now we enter the question, what do you need to succeed in calculus? This brings us to the objective of this curriculum. What do you need to succeed in calculus? Again, if you've taken calculus, you know the answer. But most people in the United States, they have not. So they have no clue. Most people in the K-12 schools, most teachers have not taken calculus. They don't have a clue what the purpose of this curriculum is, or how do you succeed in calculus. So in order to succeed in calculus, here's the point. Here's what I'm bringing you to. In order to succeed in calculus, you need to have a high degree of fluency in algebra. And that shouldn't be a big surprise, because out of the 3 years of math that's typically required in high school, 2 of those years you take courses that are entitled algebra. So do you see how this is all coming together? Now you might say, well, why are you telling me this? Everybody knows this. Well, no, most people do not know this. That's why I'm telling you. You're going to see some differences in my curriculum, but the reason is I'm preparing you for upper mathematics. This curriculum that you see here is designed to focus on algebra. Now, I have to mention, we're going to look at the Massachusetts Department of Education curriculum, because Massachusetts is ranked number 1 in the United States. If we go down and click on mathematics, you see the curriculum. And for many years, because of the things I've been explaining, for many years people have been telling math teachers to teach more math. More math, more math, more math. Teachers have responded to that by, again, they don't really know what that means. They don't know what to focus on, so they've just been dumping random things into the curriculum in the last 10, 20 years. And if you go over to the table of contents here, we have the traditional pathway and the integrated pathway. Again, you want to stay away from the integrated pathway. Click on the model traditional pathway, Algebra 2. And you see here we have the curriculum. And I just want to mention that there are a few things that are dumped into here kind of randomly, like vectors. Vectors are going to be covered in a physics course. There's no reason to cover that in intermediate algebra. If you try to cover vectors, it's going to turn the focus away from the algebra. Matrix quantities, statistics and probability. These are examples of things that are kind of just dumped randomly into the curriculum. Now, it's not that vectors and matrices and statistics and probability, it's not that those things are unimportant. You need to learn those things. And you should eventually learn those things before you go into college. Not so much matrices. Matrices are covered in differential equations and linear algebra. But these things should not be put into an intermediate algebra course, because they take the focus away from the algebra. It's also important to understand that vectors and matrices and statistics and probability are things that can be learned in days or weeks. They're not going to prevent students from going forward. But algebra is something that takes months or years to learn. And that's why algebra is 2/3 of the high school curriculum. So I'm going to be focusing on algebra because that's what you need to succeed in calculus. And calculus is what you need to be prepared for the STEM degrees. So the most important thing that we're going to focus on in this curriculum is quadratic expressions, everything relating to a quadratic expression or equation, solving quadratic equations with factoring, completing the square, the quadratic formula. The quadratic formula represents the culmination of almost everything you've learned in algebra. We're also going to convert between the different forms, standard form of a quadratic equation, vertex form, intercept form. We're going to graph quadratic equations, and the graphs are called parabolas. We're going to focus on parabolas that open up or down, and in my pre-calculus course, we're going to go into parabolas that open to the left and right, as well as the conics. Finding the vertex, the x-intercepts, the y-intercept, the line of symmetry, focus, directrix, everything relating to a quadratic equation. When you're done with intermediate algebra, you need to know quadratic equations like the back of your hand. That is absolutely essential. Most students, by the time they're high school seniors, if I gave them a quadratic equation to solve, most of them couldn't do it. Another thing that I focus on quite a bit is the exponent rules. Most students in high school do not know the exponent rules as well as they should. Many of them don't know barely any of the exponent rules. If you finish an intermediate algebra curriculum and you don't know the exponent rules, something went catastrophically wrong in your curriculum. We're also going to go over exponential equations quite a bit, just because it gives us an opportunity to review the exponent rules. Logarithms are not the most important thing in the curriculum, but I'm going to focus on them much more than usual because it's going to give us an opportunity to review previous math. The library of relations and the library of functions, most students do not know those as well as they should, so I'm focusing on things that I know are going to be areas where there's typically serious problems when it comes to going up into advanced mathematics. And students are going to start with the library of functions and use transformations to graph more complicated equations. And they're going to be able to do this without a calculator. Again, this is absolutely essential. I'm also going to focus on functions and function notation and domain and range and writing the domain and range in interval notation and set notation. And I'm not going to cover base 10 and base E logarithms until the end of the course. So if you notice it, we don't have those in the logarithm part of this course. They are going to be covered at the end. And I'm also going to cover compound interest, a very important application of intermediate algebra, along with continuous compounding. So I'm not going to go into every detail because that might be kind of boring. But these are some things I'm going to cover in my pre-calculus course. These things are often covered in intermediate algebra, but I've chosen to slow down and really focus on the things that I know are going to give students problems in the long term. And so the course ended up being longer than I thought it would be, but these things I'm just going to cover in pre-calculus. Again, a lot of different things are shuffled in between pre-calculus and intermediate algebra. So this course was my last effort to slow down and really make sure that students have no excuse to learn the material. After this point, we're going to start to really, we're going to pick up a lot of momentum. The complex plane we did not cover. We did cover complex numbers and imaginary numbers. But the complex plane is not really that important, so we didn't get to that, but we will go over it in pre-calculus. Polynomials are very important. Degree 3 polynomials, that is. We are going to study quadratics, as I mentioned. Those are degree 2 polynomials, but degree 3 and higher will be covered in my pre-calculus course. And binomial theorems, scientific notation, so on and so forth. These are all going to be covered in my pre-calculus course. So hopefully that gives you an idea of what my curriculum is going to be. Again, most students are not learning the algebra that they need to succeed in calculus. If you are not fluent in algebra, you won't survive the first week in calculus. And if you're not properly prepared for upper math courses, you're not even going to have the option to earn a degree in college, a STEM degree. So The whole point of this curriculum is to leave the option open for you to earn a STEM degree. And the way that you do that is by learning algebra. So you may see some differences in other curricula, but I would not trust the K-12 math textbooks and the K-12 math curriculum in general, because it's just not preparing students. Now, there are some arguments for why students should cover other things, like statistics, for example. But again, I'm not arguing that those things are unimportant. I'm simply arguing that the primary objective is fluency in algebra. Once you get that done, then you can worry about those other things. So that was the course content part of this class. Your homework today is to find the material that you need. Go out and buy your 3-ring binder, or if you're going to go the digital route, get these products working. Get signed up for your OneNote or whatever program you're going to use. And please make sure that you get these exact products. Don't just go out and buy something random. So I'll look forward to seeing you in the next class.